Hello and welcome to section 6.5. Today we are talking about kites. Kites are an interesting quadrilateral. What ends up happening in a kite is you've got these consecutive sides that are going to be congruent to each other. So you can take a look here and you can see that up here I have AB and AD. Those two things are congruent to each other. Whereas on this other side I got BC and DC, which are congruent to each other. So what we're going to say is exactly two pairs of consecutive congruent sides are there. That's what they have to have. Meaning that AB is going to be congruent to AD, and BC is going to be congruent to DC like we just said out loud. In this situation, what's going to happen is one pair of angles in this problem are going to be congruent to each other. Those angles are going to be opposite of each other. It's going to be angle D and angle B. Notice that they're kind of connected by one short side, one long side, one short side, one long side. That's what's going to cause that to happen. So one pair of opposite angles are going to be congruent to each other. So in this case, they gave me angle ABC, ABC. Well, that's going to be congruent to the other side, ADC, where D is that vertex. So angle ADC. And we also know one other thing. The connection between A to C and B to D, those are the diagonals of the kite. Those are always going to intersect in a way that makes them 90 degrees or perpendicular. So the diagonals are perpendicular to each other, meaning that A to C, and there's our symbol for perpendicular, is perpendicular to B to D. All right, so taking a look at this first example, let's actually apply some of these properties. So I've got this figure here, this kite, and they want me to find the measure of the angles. Notice that that kite is made up of a bunch of right triangles, right? We know right away that angle 3, that's an easy one, has to be 90 because it's perpendicular. The diagonals are perpendicular. So I'm going to start right there because what that tells me is that there's a 90 here. Let me switch colors so we can clearly see all the 90s. There's a 90 here and a 90 here. There's 4 90s all right through there. So immediately in this first side, I can definitely solve this problem, definitely, because this has to add up to 180. So I know I have 90 here. That leaves me with 90 left over for the 1 and the 65. So I can take 90 and subtract 65 from it, and I get 25. So I know that angle 1 is 25 degrees. Well, another property that we know of kites is actually this right here. If this side and this side are congruent to this side and this side, and they share the middle, that side's congruent by the reflexive property, the triangle on top, the big triangle on top, has to be congruent to the triangle on the bottom by side, side, side. So angle 1 and angle 2 will always be the same. Likewise, over here, 7 and this 52 are going to be the same. So I know angle 7 matches up with that 52. Which then just kind of leaves me with having to figure out what these other ones are going to be. Well, again, since this we just talked about this congruence here, what ends up happening is these diagonals also bisect each other. And we could find that with one of our other congruence statements. I'm pretty sure we've got hypotenuse leg right here would give it to us. So if this is 65, I know angle 4 is also 65. They just mirror over to each other. So I just need to figure out what angle 5 and 6 are, and I know they're going to be congruent to each other. Well, if we know 7 is 52, and we got 90 used up here already, so we already used 90, meaning these two have to add up to 90 to make up the rest of the 180, I can take 90 and subtract 52. When I do that, I get 38. So what I know is angle 5 is 38, which means that angle 6 is also 38 degrees. So lots of just using your symmetry there to see how those things symmetrically fit together, that this triangle and this triangle go together, this triangle and this triangle go together, and the whole triangle and this whole triangle go together, and you can piece that whole thing together. All right, couple more examples on the back. This one says, if RS is 10, let's just fill that in as we go. If RS is 10 and RY is 9, RU? RU, we're gonna go with RU, I think it's supposed to be a U, is 9, find the measure of QS. Well, that's gonna be pretty easy, right? Because again, we have a right triangle here. So I can find the length of US really easy. And if I know US, I know UQ. And then I can find the entire length of QS pretty simple. So you can see if I have a right triangle here, we're gonna use our Pythagorean theorem. A squared plus B squared equals c squared. Remember, the important part about the Pythagorean theorem is that the side across from the 90 degrees is the hypotenuse, so that has to be c. With the RU and the SU, I don't care which one's A or B, it doesn't matter. So we'll put 9 squared plus B squared is equal to C squared, so 10 squared. So I end up with 81 plus B squared equals 100. When I subtract 81 from both sides, I get B squared is equal to 19. So what I know when I square root this is that B is equal to, let's see, 19 square rooted. B is equal to 4.36. So I know B is 4.36 units. So if that's this side, 4.36, again, I know that QU is also 4.36. The question asks us, what's the length from Q to S? So we can see that we're going to take those two 4.36s and add them together. If I add them together, that is going to give me the length of the entire thing. So it looks like I'm going to get 8.72. So that is the length of QS. In example 3, it says solve for x in the figure. So you can see that right here, they gave me these two x values. And if you were to jump into this and not really think about it, you might be like, oh, they're equal. Set them equal and solve. No, definitely not. We know in a kite that the equal angles are always going to be the two that are in between the different sizes. So angle D and angle B are going to be congruent to each other, meaning this makes up 109 and 109, so 218 degrees of the kite. The kite's total, just like every single quadrilateral, has to be 360 degrees. So I can take the 360 and subtract the two 109s from it. So I would subtract 109 from it 2 times, or subtract 218, whichever way makes the most sense to you. So 360 minus 218 gives me 142. So what I know is these two angles make up the remaining 142 degrees. So I'm going to add those together. 5x plus 14 plus 3x plus 8. So I get 8x plus 22. I know that that has to be the 142 that I'm missing. So 142. So I've got 8x plus 22, the two equations added together, equals the remaining 142 after we take away the two 109s. So I'll subtract 22. I get 8x equals 120. And when I divide that by 8, I get x equals 15, and that is what the question asked me to find, was what is the value of x? And in the last example 4, find the measure of angle NQP. So they're asking me to find the measure of angle NQP. It kind of leaves us in a little bit of a struggle here, because I've got these angles all over the place, but we really do know a lot of information here, right? Because if this is 11x minus 23, this is 11x minus 23. We also know that diagonals have to meet in 90-degree angles because they're perpendicular. So what you can see is I actually have all 3 angles of this triangle right here. So I can add all 3 of those together, and because it's a triangle, it has to add up to 180. So I'm going to add the two equations first, 4x minus 7, and then 11x minus 23. And then I've got to add the 90 to it. So I'm going to put that with the constants over here. So my two x's give me 15x. Negative 7 and negative 23 is negative 30. Negative 30 plus 90 is positive 60. Set that equal to 180. So I'll subtract, and I get 15x equals 120. I divide by 15, and I get x equals 8. Again, if you stop there, though, you're not going to get the right answer, because if it equals 8, we need to make sure we plug it into angle NQP. Well, my issue I have is that angle NQP is this whole angle. But I can plug the 8 in here and figure out how big this is. Remember, however big this is, the angle right here is the same length. So I'm going to plug in the 8 here. So 4 times 8 minus 7. Get 32 minus 7, which is 25. So again, what I know is this angle's 25, which means this angle's 25. So the measure of all of NQP is the sum of those two. So 25 and 25 together is obviously 50 degrees. So that is the measure of angle NQP. Hope this helped out. Thanks so much for checking it out. If you need any help, please let us know so we can assist you in class. Have a great day. Bye.